Welcome to a tutorial on Sandia National Labs Structural Simulation Toolkit micro version 2.3.0. I'm going to be using a fresh installation of CentOS 6.3. This is a fresh install, so I've just run yum update and yum upgrade, so I've got all the current packages. And the first thing we're going to do is install some more packages that are specific to SST. So we're going to go out, grab these packages. Hopefully you have a fast connection. This is 51 megabyte download. So a little bit of background. SST is a framework for component simulators, and for example we can use the Gem 5 processor simulator and the DRAM sim for the RAM simulation. And SST is the framework that allows these components to interact. This video is just going to cover the installation of SST Micro 2.3.0, and I'll demonstrate how to add in those component simulators in later videos. Alright, so once this is finished up, then CentOS needs to have some special commands to run MPI. So here we're just saying module add openmpi into the bashrc file, and then we're going to run source against bashrc to make that command available, and as a check, now we should have MPI run as a valid command. I'm going to steal a few commands here. I'm going to make some directories. Right now in my home directory I have nothing out of the unusual for CentOS, and here I'm going to make a directory called SST, and then make two subdirectories, local and scratch. Local is where I'm going to install SST, the program, and scratch is where I'm going to save the source code prior to installation. And within scratch I'm just making a src directory, and in that is where we're going to download our Boost. Once we've got Boost downloaded, now we're going to extract it and then go into the directory cd boost, and then use bootstrap and tell it where we want to install Boost to be installed to. So the next command after that finishes is going to make a small edit to the configuration file using sed, and we're just adding using MPI so that when Boost is built, then it allows for MPI to be included. So we'll kick off the installation with b2 install. Once that's finished, the next command that we're going to run here is an echo, and we're going to export the variable ld library path. This will make Boost and MPI present in that variable. Right, so pay attention to the time here, it's 2:10. We'll come back when this is finished. Alright, so Boost just finished installing, and so the next thing we're going to do is put the library path variable to use Boost, and then we'll run the source. Alright, and then we're going to go into the source directory again, and then we'll grab the SST installation package. 31 megabytes, click download, then we'll extract it with tar. Once that's extracted, we'll go into the directory that it created and then do autogen. So see what's here, autogen. Once that's finished, then we'll run configure, and with configure we need to tell it where we want to have SST installed. So that's this SST local, SST 2.3.0, and then with Boost, and we're going to give it the direction and the location of Boost there. So right now configure is going through and checking that all the required software is actually installed and available. So if you ever run into problems, the first place to look will probably be after you run configure. There's a config.log, and the developers would like to know what happened during your configure process, because this is determining the availability. So you'll want to be able to give them the configure.log contents. This is just a record of what happened during the configure process. So this is the command I ran, and these are all the results of the tests. So these are the tests occurring, and seeing what's available and what's installed, and then all that is logged for our next command, which is make all. So make all is going to take a little bit of time. We'll start at 234 and come back in a little bit. Now that make all has finished, we're going to run another make install. This will be their final installation command. It doesn't take too long. So once that's finished up, SST will be installed, and we can verify that by running the version command. So we're going to change into the directory where it's installed to, and we can run /sst version. And this will show us the version we're running. So SST is now, the framework has now been installed, and in our next videos we'll be installing the component simulator GEM 5 for the CPU.